Today we want to consider formulas used in calculating mole. But first of all, what's the meaning of mole? When we are talking about mole is just a term that is used in describing a package of things, a bundle of things. Like for instance now, a dozen of biro, a dozen of pencil. A dozen of biro, a dozen of pencil can mean a mole. So a package, a term that is used to describe a package of things is what we refer to as mole in chemistry. And there are so many units, there are so many formulas that we can link to mole. For instance, 1 mole of a substance is equivalent to Avogadro's constant. And that Avogadro's constant is 6.02 times 10 to the power 23. 1 mole of a substance is also equivalent to molar volume. And that molar volume is 22.4 GMT. 1 mole of a substance is also equivalent to the molar mass of that substance. So there are different units we can equate or link a mole of a substance to. Mole, or let me say molar solution. We are talking about molar solution now. Molar solution. So molar solution means concentration, and the unit of concentration is a mole per dm. So mole in this case is equal to concentration in mole per dm. Concentration in mole per dm. Concentration in mole per dm multiplied by volume.
Sounds by cumulative.
Volume. This volume must also be in dm. But if this volume is not in dm, you are going to convert that volume by dividing it by what? By 1000. If that volume is in centimeter cube, lesser than 1000. Because that volume is still 1000 centimeter cube, is still correct. It's still a standard value. It's still a standard value. But if that volume is lesser than 1000, you are going to convert it to apply for this formula. So lastly, these are the formulas that are used in calculating mole. From here now, you can now derive as many units as possible. You can derive as many formulas like for me now. I can derive another 3 formulas from here. From this one only, I was just using this one to derive formulas for you. When you are solving questions that involve moles in objective, because at the time when you are solving questions that involve moles in objective, it might require 2 steps. Instead of you now using the 2 steps, the summary of the derived formula I want to give you now, if you write that formula, you get to answer straightforward. But if there are so many in theory, you might need to write that 2 steps because of mark. Do you get what I'm saying now? Okay, so from here, we can say a mole is equal to mass over molar mass. A mole is equal to number of particles divided by 6.02 multiplied by 10 to the 3. We can say a mole, when you are talking now of molar volume, is equal to volume divided by molar volume. A mole is equal to PV divided by RT. A mole, which is when you're talking about molar solution now. This solution is in dm. That's the thing we have. Anything solution, the standard value for any solution must be dm in chemistry. So, and that's why we have form in mole per dm cube multiplied by volume in dm. Alright, and let's look at the applications of the formulas. Now, the slide will display on the screen now. Calculate the number of moles in 5.3 grams of sodium tricarbonates 4. Calculate the number of moles in what? In 5.3 grams of sodium tricarbonates 4. Note that we are given mass. you are given mass in that question. And because you are given mass, remember that I said mole is equal to mass over molar mass. So the compound sodium thiocarbonate 4 is what we are going to calculate its molar mass. We are going to calculate the molar mass of sodium thiocarbonate. And when you are calculating the molar mass, according to the formula of sodium thiocarbonate 4, you have Na2CO3. So sodium atom is 2, carbon atom is 1, and oxygen atom is 3. So each of them, they are going to multiply their number of atoms with their atomic mass. So atomic mass of sodium is 23 multiplied by 2. Then we add it to atomic mass of carbon, which is 12. Then we add it to the atomic mass of oxygen. So oxygen, we have 3 atoms of oxygen here. 3 multiplied by 16 to give us 48. Then we add everything together. The sum of those masses will give us 106. So 106, the sum of the masses will give us 106. So after then we go back to our formula, which is mole is equal to mass over molar mass. So the mass we were given there was 5.3 grams. So 5.3 grams divided by 106. And then we are going to have 0.05 mole. Calculate the number of mole in 4.25 multiplied by 10 raised to the power of 21 atoms of copper. Now note that 4.25 times 10 raised to the power of 21 is the number of atoms of what? Of copper. So in that, we have given number of atoms of copper already, and remember, I said when you are talking about number of atoms, number of ions, number of molecules, you are going to use mole is equal to number of particles divided by 6.02 times 10 raised to the power of 23. So in that case, you just substitute the value in the formula, and then we are going to have 7.06 multiplied by 10 raised to the power of 3. I'm going to display the practice question on the screen right now. You can write this question down, try it, solve it, and send the answer to the comment box. Now, very fast, another thing we are going to consider is the relationship of mole with other parameters. When you are talking about mole and then with chemical equation, talking about mole with chemical equation, and that's what we are going to consider now. Now, look at the equation displayed on the screen. Anytime you are dealing with mole involving chemical equation, the number one thing you need to know is that that chemical equation must be balanced. If that chemical equation is not balanced, then your calculations will be totally wrong. And what do I mean? Number of atoms at the product at the reactant side, the total number of atoms at the product side must be the same as the total number of atoms at the reactant side. The total number of atoms at the reactant side must be the same as the total number of atoms at the product side. So vice versa, when you add their atomic masses together, automatically the atomic masses of the reactant side will be the same as the atomic masses of the product side. So in that regard, then whatever calculations you do afterwards will be correct. Now look at what is displayed on the screen. From the above equation, what is the amount of hydrogen that will be produced if 7.2 grams of zinc reacted completely with dilute acid? Now, what are we going to do there? Number one thing that we are going to do from that equation is that when you check that equation carefully, the question only makes mention of two different elements with values. For instance, we are going to lay zinc and hydrogen gas together according to the statement of the question. So that is what the question was talking about. So step 2, we are going to link the mass of zinc because the question was talking about the mass of zinc and the mass of hydrogen. If you go through the question talks about the mass of zinc and the question talks about the mass of hydrogen. And that's why we are going to link the mass of zinc according to the equation and the mass of hydrogen. The step 3 there. When you are balancing the chemical equation, you will discover that 1 is in the front of zinc because 1 is not written, that's why we say it is 1. If another number is written in front of zinc, then we will say, we will call the number as the number of mole or as the mass of zinc. So, we have 1 mole of zinc multiplied by 65 grams, that's the molar mass, or that's the atomic mass of zinc. We equate it to 2 grams of hydrogen because one atom of hydrogen is 1 gram. So 2 atoms of hydrogen will be 2 grams. And when we now go back to the question is now saying that we have 7.2 grams of zinc. So we are left with the mass of hydrogen. So going by that slide, we just make the S gram, we just make the unknown mass to be S gram. And by the time we make S gram the subject of the formula, we are going to have 0.22 grams. The one that relates mass and molar volume. Now in this case, you are going to be having you are going to be dealing with mass on one hand and volume on the other hand. Now let's check the chemical equation display and the question afterwards. From the above equation, calculate the volume of oxygen produced at STP through the decomposition of 6.4 grams of potassium trichloride 5. Alright, just like we did in the first place. In this case now, we are concerned with potassium chloride and oxygen. So we are less concerned with potassium chloride. And that's why we link potassium together, we link potassium chloride and oxygen together. Then we will proceed to their number of moles. The number of moles of potassium chloride is 2, while the number of moles of oxygen that is there is 3. Alright? Then we are going to deal with mass because the question is talking about the mass of potassium chloride. And at the product side, the question is talking about the volume of oxygen. And remember that molar volume of gas is 22.4 gmp. So linking them together, just like the first slide, we are going to make S our unknown volume, and making S unknown volume, making S the subject of the formula, the volume of oxygen gas that will be produced is 1.76 gmp. Till I come